So, we're going to talk today about two main types of bonding. Oh, we got to pause. Where's my mouse? There's my mouse. Pause. All right, let's try this again. We're going to talk about two types of bonding, and the second one is probably new. Your teacher in Science 9 might have covered it optionally, but it's not officially part of the curriculum, so I'm going to be teaching it as though it's brand new. First time we're going to talk about is ionic compounds. First of all, a compound, that can go in the first blank, in case you're wondering. A compound is a substance that's made up of two or more different elements combined together. This year, Dylan, we're primarily going to be looking either at two elements or one element and one what's called a polyatomic ion. We're not going to be looking at there are compounds that are literally several hundred elements long. We're not getting there at all. In fact, most people don't get there unless they're getting their PhD in chemistry. We're going to keep it, I can't say simple because it's tough, but we're going to keep it as simple as we can. An ionic compound is a compound made up of two or more different ions. And what's an ion? Let's talk about that. Recall, metals form positive ions because they lose electrons. And what's the opposite of metals? Non-metals form negative ions. Mr. Dueck, are you saying that non-metals form negative ions? You're suggesting that non-metals form negative ions. Is there an easy way for us to remember that, Mr. Dueck? I got nothing. I suck as a teacher. Somebody at the door. Hang on. Another interruption. Metals want to lose electrons. Non-metals want to gain electrons in order to become stable. So an ionic compound must be formed by ions having opposite charges. You learned last year in Science 9, looking at electricity, that like charges repel. So if two metal ions wanted to form a compound, they couldn't because they would just repel each other. You need to have some positive and some negative. You need to have, so if ions had the same charge, they will repel each other. No compound will be formed. So ionic compounds must be formed by a metal and a non-metal. And that's going to be, Tyler, how we identify them, because you're going to be learning more than one compound this year. And one of the first things you're going to ask whenever you see a new compound is, what kind is it? Hey, if there's a metal, it's ionic. Oppositely charged ions, positive and negatives, will attract each other because a force exists between them. A static charge, you see it on dry days between clothing. They want to cling to each other. They are oppositely charged. And this attractive force on the atomic level is called an ionic bond. An ionic bond is when two ions, one positive, one negative, attract each other and want to stick together. Remember that atoms become ions when electrons are gained or lost. Julia, just keep up from where we are. You'll get the rest of the missing stuff later, but don't fall behind trying to keep up, okay? So you can gain or lose electrons. And an ionic compound forms when the number of electrons that a metal needs to get rid of to become stable is the same as the number of electrons that a non-metal or metals need to gain to become stable. In other words, in an ionic compound, Taylor, if you add up all the positive and negative charges, they should always work out to zero. Otherwise, it's not a stable compound. Otherwise, it still wants to attract or repel more stuff. Here's Mr. Dueck's helpful hints to drawing ionic compounds. I put it in a box. When you're studying, this might be one of the boxes that you want to make sure that you have wrapped around your brain. First of all, you always check, I put this in all caps, which should mean I'm shouting, you always check to see if there is at least one metal in the compound. If there's no metal in the compound, it's not ionic. What is it? Probably covalent, coming down the pipe later. Count the number, when you're drawing pictures, of metal and non-metal ions. The ion that has the fewest number of them, you put in the middle. If there's equal numbers, draw side by side. Say what? Trust me, Cameron, in it. When we do the diagrams in a second, it'll become clear. Since ionic compounds are made of ions, each ion must have those funky square brackets and then the ion charge around it. That's my way of saying I'll take marks off on a test if you forget to put them there. What is the ion charge? It's right from the periodic table. We're going to not be, at least for a while, we're going to be avoiding the multivalent ones, the ones that have more than one charge. We're going to stick with the ones, today at least, that just have one charge. If a compound is stable, if it could exist in real life, then the metal atoms in the compound must lose all of their valence electrons. The metal atoms must get rid of their entire outer shell. Oh, and the non-metal must fill up its entire outer shell. Let's do a practice. Here's a little checklist. You're not going to need to memorize this. I think I'm going to give you enough homework that this will just become part of your procedure. First thing I always ask is it ionic? What I look for is there one metal in the compound? Now, our compound is NaCl, which we learned last year was called sodium chloride. So the first thing you want to ask is one of these a metal? Metals are on the left side of the periodic table. Find sodium. Is sodium a metal? Yes. Yep. So is this ionic? Yep. Put a check mark there. How many metal atoms are there? How many sodiums are there in the formula? It's meant to be really obvious for this first one. You're right. One. How many non-metal, how many chlorides are there in the formula also? So I'm just going to draw them side by side. If there was, for example, one sodium and two of something else, my picture would look like this. Don't write this down. I'd put the sodium here, and I'd put the other two on either side of it, kind of surrounding it. That's why I said you want the fewest number of ions in the middle of your picture. Draw. Okay. Let's zoom in. First thing I'm going to draw is the Bohr diagram. I'm going to draw sodium here, and then just to the right of it, I'll draw chloride. You know what? If you wrote that bracket down, that's fine, but I've learned sometimes my brackets need to be bigger, so I'm going to draw first. First thing I'm going to do is the nucleus. Yeah, this bracket's going to have to move too for a bit. And inside the nucleus, I put protons and neutrons. How many protons for sodium? 11? 11p. How many neutrons for sodium? And I don't have my periodic table in front of me on purpose because I don't want to do these answers. You guys are going to have to do them. So what's the mass of sodium? 23. Take away 11 is 12 neutrons. What row is sodium in? So normally it would have 3 shells, but it's going to lose that outer shell. I'm going to be drawing 2. Here's the first shell. Yoink. How many electrons in the first inner shell? Remember our something, comma, something, comma, something, comma, something rule, the 2, 8, 8, 18 rule. 2, 1, 2. Pair them up because that's a full shell. How many in the next shell? 8. You can count across. You can memorize it, but also it's on your periodic table if you just count across. Now, Rachel, look up for a second, folks. Don't write this down. Technically, it's 1, 2, 3, 4, pair, 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 pair. But if you know it's full and you just go 2, 2, 2, 2, you go ahead. I'll always do the circle just to remind you that we're pairing them up, but it's 2, 2, 2, 2, 2, 2. Now, if this was an atom, don't write this next bit down, don't write this next bit down, I would do that and I would say, woohoo, but it's an ion, it's gotten rid of that. Did I say ion? And its charge is plus, yes, from the periodic table? So do you have to memorize all this information, Alice? No. Do you have to know how to read that pink table? Yeah. What is it combining with? Chloride. There's the nucleus. How many protons in the chlorine? Julia and I, we just did this, but I've forgotten. How many was it? 17? And was it 19 neutrons? Is that what you get when you subtract? 36 take away 17, 19? Okay. What row is it in? Chung, chung, chung. How many down? So how many shells will it have? 3, and the third one is going to be full. So first of all, inner shell, 2. Middle shell, 1, 2, 3, 4, 5, 6, 7, 8. Outer shell. Yes, the tongue helps. 1, 2, 3, 4, 5, 6, 7. And just to show you, I'll do the final electron in black. That's the one that it picked up from sodium. You don't have to go multicolor, but I will, Alex, because it's a little clearer.
Well, thank you. Appreciate it.
No problem. Why does it, now again, if it was just an atom, it would look like that. But it's an ion, so it's filled its shell. Did I say ion? What do I have to remember at the end? Square brackets. Minus. Dylan, you remember I said for a compound to be stable, all the pluses and all the minuses have to cancel out. Do they? Yep, this is a stable compound. By the way, what is NaCl? It's table salt. Right? It's what you put on French fries. Although we table salt, we tend to enrich it with some iodine because that helps your diet, gets rid of goiters and other stuff. But basically it's that with a few other things inside. Someone said sodium chloride, that's its name. I can't just call it salt. Later on in this unit, you're going to learn there are a whole bunch of things that belong to the salt family. Ty, you going to make it? You going to make it? Because you're not looking good. Sure? Okay. Lewis diagram, much easier. Doesn't take up as much room. Lewis diagram. I write the symbol. What's the symbol for sodium? Nah. No. Tell me the symbol for sodium. Nah. No. I mean, yeah, okay, there's the joke, right? Na. Lewis diagram, all we care about is its outer shell. Don't write this next bit down. If it was an atom, it would be that. But it's an ion, so what can you tell me about sodium's outer shell? Nothing. It's an ion. Did I say ion? And for those of you that just jumped in, this is how you do Lewis diagrams. It's the symbol, and all you care about is how many electrons in the outer shell. And there's a lesson online. You can watch that in more detail. I also think this will help some of you with the homework from the last day, too. Chlorine, chloride, Cl. 1, 2, 3, 4, 5, 6, 7. That's normally its outer shell, but it's an ion. It picked up the extra electron from sodium. Did I say ion? Which one's less work to draw, Bohr or Lewis? Which one do I like better, Bohr or Lewis? You know what? Probably on your test, I might make you draw one Bohr compound. I'm not going to do more than that. Then I'm going to flog Lewis. This is so much nicer. And I think it's less confusing. Let's go to the checklist, answer the rest of it. So, draw, we did, both types. Did we do the square brackets? Yep. Did we add the ion charge from the periodic table? That's what PT stands for. Yep. Double check, do the nonmetals have a full valence shell? Yep. Have the metals lost their valence electrons? Yep. This is kind of, Taylor, the mental checklist that you want to go through in these diagrams. Let's try another one. Yeah, I figured I did one board diagram and then I had enough. Lewis diagram only. Okay. Na2O. First of all, how do I know that that's ionic? Is there a metal in it? Sodium again. So, is it ionic? Yep. How many sodiums are there? 2 or 1? How do you know, right? See, by the way, you see where we're looking at, the little subscript? And remember, if there's no subscript there, what number do we assume is sitting there invisibly? 1. How many oxygens are there? 1. Draw. I'm going to put the oxygen in the middle with the sodium on either side because there's the fewest number of oxygens. In other words, Sage, as a picture, it's going to look like this. Oxygen's going to be there. Nah. Let's do the Lewis diagrams. Oxygen. How many electrons will there be in its outer shell? Well, normally 1, 2, 3, 4, 5, 6. But it's going to pick up 1 electron from the left-hand sodium, 1 electron from the right-hand sodium. That makes it an ion. Did I say ion? Oxygen, what's its charge? 2 negative. Can you see from the colored picture why it's 2 negative, right? It's picked up 2 extra electrons. Sodium. Now, sodium, normally, if I was doing a Lewis diagram, would have 1 electron there if it was an atom. But it's an ion. How many electrons will it have in its outer shell? None. Did I say ion? Did I say ion? There is the Lewis diagram for a sodium oxide molecule. Double check if you add up the pluses and the minuses. Is this stable? Yep. This could exist in real life in nature. Let's go to our quick checklist to make sure we didn't miss anything. Square brackets, we got them. Ion charge, we got them. Full valence shell, full valence shell. Aluminum fluoride. Is there a metal in this compound? So it's ionic. How many metal ions are there? 1. How many non-metal ions are there? I'm going to put the Now, this one here, put your pencils down for a second. I'm going to draw this like this. I'm going to go aluminum, and I'm going to put a fluoride, and a fluoride. That's technically wrong because I'm drawing this on a flat piece of paper. In reality, so my setup is going to look like this. Aluminum here, and I'll put a fluoride here, and a fluoride here. Although, arguably, it should be like an equilateral triangle, one there, whatever. I'm not going to be that fussy. Let's do aluminum in the middle. Now, normally for aluminum, I would go like this, 1, 2, 3. But it's an ion. So how many electrons does it have in its outer shell because it's a metal? Did I say ion? What's the charge on aluminum? Normally, each of these fluorides would have 7 electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. But each of them has picked up 1 extra electron from aluminum. Giving them the full outer shell of 8. Julia, for what it's worth, I won't ever bring one of the 18s in, because the fourth row is 18. I'm not going to ask you to draw one with 18 electrons in its outer shell. That'd be ridiculous. So we'll stay in the top, basically 3 rows and a bit. Are these ions? Double check. Does everything add up to 0? This is stable. Have we got square brackets? Yes. Outer shells? Yes. I'm not going to fill out the checklist anymore. I'm just going to do it internally. So far, so good. The bonding there should not have been new. The diagrams there should be new, the Lewis diagrams. But you folks did ionic bonding last year. There's a second type of bonding. Covalent. Covalent. In many ways, a more interesting kind of bonding. So what I wrote here is 2 nonmetals can come together and become stable. How? Well, if you want something and I want something, hey, maybe we can just share. For a covalent bond, you cooperate, you share electrons. For a covalent bond, you cooperate, you share electrons. For an ionic bond, I want it. I want the electrons, is how I remember them. Ionic is I want it. The nonmetal says I want all the electrons. The metal can't have them anymore. For a covalent bond, it's between 2 nonmetals. Covalent, cooperate, share. 2 metals can't come together because, Ty, if you want to get rid of 3 electrons and I want to get rid of 3 electrons, there's nothing we can do. Those electrons got to go somewhere. Out of luck. But 2 nonmetals can become. If you have 7 and you just need 1, I have 7 and I just need 1, maybe I'll let you borrow one of mine while you share one of yours with me. That gives me 8 to play with and you 8 to play with, as long as we're careful. Gives us our full outer shell. So when electrons are shared between 2 nonmetal ions, they form a very strong, much stronger than ionic, a very strong bond called a covalent bond. So the prefix co, think cooperate, think together, and valent, outer shell. We're going to share electrons in the outer shell. For what it's worth, a maximum of 1 covalent bonds can exist between 2 atoms, which means that you can only share 2 electrons at a time. You share 1, I share 1, for a total of 2. And some nerd terminology. If we're sharing electrons, that pair is called a bonding pair. If I have 2 electrons but they aren't being shared, we call those a lone pair. I don't know that I'll test you on those words, but they'll show up in your notes and in your homework, and it's kind of like be familiar with it. Hey, let's give you some hints on drawing these. This is all caps. All caps technically means shouting. Always check to see that all the atoms in the covalent compound are nonmetals, the right side of the periodic table. If there is a metal, then it's ionic, not covalent. Just like before, count the number of different types of atoms, and the one that's the fewest in number, that goes in the middle of your picture. Do you draw square brackets this time? No. They're not ions. And then when I taught this 2 years ago, I used this formula. I'm going to chuck it. I'm just going to see if we can kind of tie into it, figure out cleverly from what we know of atoms and charges and stuff has to add to zero, full valence shells, if we can figure this out. Oh, and then each bond counts for 2 electrons. Then add enough lone pairs of electrons to make sure they have full valence shells. Handy hint, put a star next to this. This is Mr. Hofbrinkel. This is the acronym that I stole actually from Mrs. Howard, who retired last year. There are certain nonmetals that if they are by themselves, refuse to be by themselves. They will always pair with themselves. What are they? What does the H stand for? Which element is that? Hydrogen by itself is never H. It's always H2. It bonds with itself. What does the O stand for? O2. In fact, you'll see oxygen tanks are even labeled O2. They're not even labeled O. Oxygen, if it's by itself, will bond with itself to get a full electron shell. What does the F stand for? Fluorine, the Br? Bromine, bromine. I is iodine or iodine if you're British. N is nitrogen. Cl is chlorine, not carbon. This capital C has an L next to it. Yes?
Question with the whole oxygen tank thing. So, when screwdrivers use oxygen tanks,
Yep.
since it's pure oxygen, wouldn't you be able to do more, athletic-wise, and do have
It's not pure oxygen.
Isn't?
No. It's a mixture. There's some nitrogen in there as well. And all a scuba tank does, can I answer your question towards the end of class if I have time? Or if there's another class that I end short, remind me to tell the Hosendiver story, because it's good physics and it'll explain how scuba tanks work. But I can't, it's a long story and I can't fit it in now, but it's a good story. Hosendiver. I kid you not. This acronym can help you remember which elements are, here's your fancy word, diatomic. What that means, Jaden, is these elements, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine, they form pairs, covalent pairs with each other. Now, if you combine them with other elements, they don't have to be in pairs, but on their own, they're going to pair up. They are that hungry for electrons. As a little picture here, I'm going to zoom in. Okay. If you take 2 fluorine atoms, each of which needs 1 electron, well, what they can do is they can sit side by side and they can pair. So there is the bonded pair right there, and each of these pairs would be called a lone pair. So there's 2 fluorine atoms sharing a covalent bond or forming a covalent bond. The shared pair gives each one a complete, remember the fancy word, octet, group of 8. Practice. I think I did a checklist as well. Yes? Yeah. H2O, water. Okay. I see hydrogen and I see oxygen. Are any of those metals? What that means is this is covalent. How many hydrogen atoms are there?
2.
How many oxygen atoms are there? Ignore the formula. Which one am I going to put in the middle? Oxygen. So I'm going to zoom in again to like 350 times. Okay. So a Bohr diagram of oxygen is going to look like this. Here is my nucleus. How many protons? How many neutrons? By the way, Julia and Rachel, is that big enough? Can you guys see? Because you guys are kind of in the back corners. Yeah? Okay. 8 neutrons as well? Okay. Oxygen has 2 on the inner shell. And then in the outer shell, look up. Look up. It has a lone pair, a singleton, and a singleton for 6. Which means, my angels, that a hydrogen is going to go there and a hydrogen is going to go here. Because that's where we're missing electrons. Except, I'm doing the symbol. Sorry. If you did the symbol, that's fine. Hydrogen has 1 proton, no neutrons. Do the math. It's the simplest atom. Hydrogen has 1 proton, no neutrons. Hydrogen has 1 electron. It's going to be overlapping next to that pair. Hydrogen has 1 electron. It's going to be overlapping next to that pair. And then I try and draw the shell like that and the shell like that. By the way, if you tilt your head sideways, you'll see why water is often called the Mickey Mouse molecule. It's actually one of its slang terms. That turns out to be actually hugely important to life, but we'll talk about why later. So you ready? Sage, count with me. In the outer shell of oxygen, count 1,
2, 3, 4, 5, 6, 7, 8.
full octet. In the outer shell of hydrogen, now hydrogen only needs 2. Julia, count with me, my angel. Check. 1, 2, check. Okay? This is how a covalent bond can form. Square brackets, no, this is not ionic. I do think Bohr diagrams are helpful to visualize what's going on for covalent. They're still a pain to draw. Let's draw a Lewis diagram. O, H, H. Yep. Like that, you mean? Because I happen to know that water forms that Mickey Mouse molecule, but I wouldn't take marks off if you drew it that way. This is, again, me being a nerd and being reluctant to show you something that's sloppy. In actual fact, I think they form right here, 123-degree angle, but that turns out to be hugely important. It's why water can dissolve things, because other molecules can get stuck in here, and that's why water can wash away dirt and things. As I said, there's a reason why water does the things that it does. Okay? Put your pencils down. Look up. Don't turn your brain off. To draw this, I would go 1, 2, 3, 4, but then the symbol for a shared pair is a horizontal or vertical line. A horizontal or vertical line. We used to do this with dots on the end to show you the 2 electrons. We've long since stopped doing that. We just draw a line. Whoops. We just draw a line, but what this counts for is 2 electrons and 2 electrons. So now, copy that out. That's our symbol for a bonded pair. So ready, Conlon? You're going to count with me. This is tricky. Count. 1, 2, 3, 4, 5, 6 counts as 2. 7, 8 counts as 2. There's our octet. What about hydrogen? How many does hydrogen want in its outer shell? It's in row 1. How many does it want in its outer shell? Careful. To have a full, it has 1. It wants, so you ready? 1, 2, done. 1, 2, done. So you got to be careful when you're doing your count tie to realize a covalent bond. We symbolize shared electrons with a line. What I always do is I just count on either end. So actually, Conlon, I would go like this. 1, 2, 3, 4, 5, 6, 7, 8. Because in my mind, I'm kind of pretending there's an electron on either end like a barbell. That's not what's going on, but that's how I remember. Let's check our checklist. Oh, add valence shell electrons. Have we got full shells for all the ions? Yep, we're good. CH4, I think this is the last Bohr. You know what? This is the last Bohr diagram I'm going to do. And then I'm going to do Lewis. You guys have been great. I'm hoping about 10 more minutes and I can shut up. But like I said, this is a head scratcher. You got to really concentrate. CH4, is C a metal? Carbon. It is not. Okay? It's a bit of a weird one, but it's not. What about H, hydrogen? It is not. So is this ionic or covalent? So I'm going to put a little check mark. I'll even write a little COV. How many hydrogen atoms are there? How many carbons? So what am I going to put in the middle? Carbon in the middle, and then one hydrogen above, below, left, and right. Although, again, technically that's wrong. What you have to do is imagine a three-dimensional kind of a three-sided, four-sided pyramid thingy, whatever. I'm not being that fussy. Bohr diagram. Carbon in the middle. So here's the carbon. You know what? Carbon I'll do in black because carbon is like charcoal. So here's the carbon nucleus. Yeah. How many protons in the nucleus? How many neutrons in the nucleus? Carbon is on what row? Row 2. So it's got a full inner shell already. Boom, boom. How many electrons does it have in its outer shell? So it's going to look like this. One on the top, one on the right, one on the bottom, one on the left. How can it get more electrons? Well, we're going to put a hydrogen. Sorry, not an H. I got to draw the nucleus. A nucleus for hydrogen right there. 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 And hydrogen has one proton, one proton, one proton, one proton. How many electrons does hydrogen have? One. Bonk. But it's going to share that other one with carbon. And now, woohoo, this hydrogen has a full outer shell. It's going to share with carbon. And now, woohoo, this hydrogen has a full outer shell. It's going to share with carbon. And now, woohoo, this hydrogen has a full outer shell. It's going to share with carbon and woohoo! Now we have a full valence shell. I think the Bohr diagram, again, I think that's kind of a clearer idea of how stuff is overlapping. Still way too much work. Let's do a Lewis. Carbon. Oh, I said I'd do carbon black. Let's be consistent. Carbon. Hydrogen. 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 It's going to look like this. There's a pair of shared electrons. There's a covalent pair. There's a covalent pair. And now that might look like only 4 electrons on carbon, but remember, each line counts for 2. 2, 4, 6, 8. Carbon's happy, and each hydrogen has 2. Now, this also starts to explain, Alex, why molecules are the shape that they are. This is CH4. This is methane, I think. And these bonds are strong enough, there's enough energy contained in here that if you add a match to break the bonds, it'll explode. That's why methane explodes. Double check my checklist. I said ignore the formula. Have we got full valence shells? Yep. A couple more and we're done. Turn the page. First, I'm going to say I'm not doing the Bohr diagram.
So maybe we don't need to do
You're going to, in the textbook homework, occasionally have to draw Bohrs, and I will, but I'm just saying in our notes. This one here, ionic or covalent? Okay, so ionic, let's see. There's going to be lithium and fluoride. Lithium, oh, let's make a little note here, ionic. How do I know it's ionic? Because lithium's a metal, right? Lithium, how many, this is ionic, how many electrons will lithium have in its outer shell? Normally this, don't write that down. How is it going to bond with fluoride? What's it going to do with that electron? It's going to lose it. So, boom, boom, ion, plus. Fluoride normally looks 1, 2, 3, 4, 5, 6, 7. But what will its outer shell look like now that it's an ion? Where did it get that 8th electron from? Ionic. I want it, says the nonmetal. Lithium can't have it. And I said ion, so we draw the square brackets and the minus. This one is tricky. Again, skip the Bohr. O2, is there a metal? In fact, this is Mr. Hofbrinkel. This is a diatomic. So how am I going to draw this? Well, I'm going to put an O there, and I'm going to put an O there. Okay. This one I had to look up because it's weird. First of all, how many extra electrons does each oxygen want to fill up its shell? Which one? 1 or 2? One extra gets them to 7. Wants 2 extras. Because look, oxygen is 6 over from the right. It wants 2 extras. What that means is they're going to have to share 2 with each other. It's going to look like this. Pair, pair. How many electrons does that count for grand total so far? 4. How many are left to fill up the octet? How big is the octet that I want to fill up? 8. How many do I have here? So how many are left? I'm going to draw it like this. This is technically wrong. Really what happens is these remaining 4 kind of spread out evenly, but I'm not going to get that high tech. In other words, really what I should do is 1, 2, 3, 4, and kind of like a little pattern. Don't worry about it. Take Chem 11 if you want to get fancy schmancy. All I know is I've got 8 in each outer shell and 2 covalent bonds. This is very strong. This is why O2 forms so quickly. That's why we store it as O2. Next one. What kind of bond is this? Ionic or covalent? I'm just going to write down ionic, and I'm going to skip it. I'm going to gamble that you've got the hang of doing the ionic ones, and if not, you'll kind of get the hang in practice. I said draw Bohr diagrams of the following covalent or Lewis. You know what? I'm not going to draw a Bohr, and we already did water. Let's try OF2. Skip the Bohr. Let's zoom in. So I've ditched the checklist. First of all, how do I know that this is covalent? Oxygen, not a metal. Fluorine, not a metal. Covalent. Which one is there fewest of? So my picture is going to have an O and then F over here and an F over here. Okay? There is going to be one covalent bond here, one covalent bond there. Why? How do I know one? How many extra electrons does fluoride need? Just one. So there it's sharing one with oxygen on either side. How many electrons does this line count for? So how many does oxygen have right now? 4. How many more does it need? Pair. This sort of looks like somebody shouting with their mouth, ah, and their arms stuck out. I know. How many electrons does fluoride have right now? With this line, what does it count as? 2. How many does it want? Also 8. So how many more do I need on the fluoride? 6. 1, 2, 3, 4, 5, 6. Pair. Oh, and 1, 2, 3, 4, 5, 6. That is a Lewis diagram of the covalent bond molecule, oxygen difluoride. And you haven't learned how we name those yet, but that's coming down the pipe. Is that okay? I'd like to do more, but I'm kind of losing you, and I should, because you guys have been very, very patient. I planned on doing a bunch more, but you know what? Here's what I'm going to say. Your homework for next week, Wednesday, keeping in mind I'm going to be giving you a little bit more this Wednesday, which means you can spread it out over Thanksgiving or not. I don't like giving homework over a long weekend, but I'm kind of stuck with it. I wrote from the textbook, Complete Activity 4-1B on the handout that I've given you. Say what? Oh, I'm going to give you a handout in a second. And then you can finally complete the handout that I gave out like a week ago called Section 4.1 Homework. Remember, it looked like this. I attached the answers to it. You're going to mark your homework before turning it in. You can expect a quiz sometime in the next couple of classes. I'm going to be asking you to tell me the number of protons, neutrons, and electrons in any atom or ion. Draw Bohr and Lewis diagrams of atoms and ions, but I'll stay near the top of the periodic table. Recognize Bohr diagrams of compounds, maybe draw an easy one. Definitely draw Lewis diagrams of compounds. A good way to study for the quiz would be to read the questions on page 183 and just answer them in your head. And if you can't, write those ones down and look up the answers or look in your notes. So going back to here, give me a second. So can you all open in your textbooks? It's section 4.1b. I gave you the page number. What page number is this in your textbook? 181. Let's go find it in my copy here. It's called Activity 4-1B, Modeling Compounds, but I gave you a handout to kind of work things through. So it's giving you some instructions very similar to my checklist. If my checklist, or if you're having trouble, if you don't understand my checklist, you can follow the textbook instructions. So I said this in the actual handout. Where are you? Activity 4-1B. So do numbers 2 to 4 and 6 to 7, but I've given you spots to write stuff. So number 2, draw a picture of Li2O right here. Number 3, and I think it's a Bohr diagram it wants you to draw in the textbook. I'm going to modify my homework, and I'm going to say this sheet here, this activity is what you want to try and get done for Wednesday. The other handout, whoop. Come back here. This one, I'll give you some time when I see you on Wednesday, maybe the first 15 minutes or so of class to also work on it. Doesn't mean you won't have to do it, but I'll give you some class time. So see if you can follow the instructions, and then so you're going to be drawing your diagrams for the various questions here. 6 and 7 is Lewis diagrams of ionic and covalent. 2, 3, and 4 are going to be Bohr diagrams. I hate them, but we need to practice. And then I also said answer the what did you find out questions just on the back of this sheet. Sorry, there's only about 8 minutes left. I was hoping to give you a lot more time, but I thought it was important that I really cover this well.